Today we are going to discuss about the total RBC count. For RBC count, so broadly we have two methods. One is called manual and second one is called automated. We will discuss mainly about the manual method, but now I am going to explain you few things about the automated method. Here we can see first method is called manual counting with hemocytometer. So hemocytometer box you will get, in that box you will get the hemocytometer slide, or you can say improved newer slide, and then pipette, then diluting fluid and everything we have, and then we use microscope and we'll do the manual method. So this is the manual process, so chances of error is high in case of manual method. But we have another process, another method, that is called automated method. So what is automated method? Broadly we have two type of automated method. One is impedance counters, so, and second one is flow cytometer counters. So one is impedance counters and second one is the flow cytometry counters. So what is impedance? First, what is impedance counters? Impedance counter detect change in electrical resistance by a cell while passing through. So in impedance matching, impedance counters, what we can do, we prepare automated machine will be there, and that automated machine we have to put sample, blood sample, and in that blood sample the sample will pass through, so direction of cell flow. So cell flow means RBC or blood is flowing in this direction in the machine, okay. And here we have electrode. So suppose this is a pipe and blood passing through it. So this is, suppose RBC WBC platelet is passing in this direction, okay. And here we have electrode. Electrode is giving some signal here, and when blood will pass, RBC will pass here, so that will change the signal. Signal means change in electrical resistance. When it will pass in this area, from this area, it will change because of the passing of the cell. It will change electrical resistance by the cell while passing through. When cell will pass through this area, it will change the electrical resistance, and that will be picked as a pulse, one pulse. So something will pass, it will just register one pulse, or amplitude will change, and that will be registered as a one cell by the machine as a one pulse, or one pulse will be counted as a one cell test. Then second test we are going to discuss flow cytometry counter. What is that? We use laser here. Laser will pass, so laser is passing, and cell direction of the blood flow is like this direction, same, okay. So cell is passing, and laser is going, and this is the detector two direction, and they will detect actually size, not only size. So while passing, laser ray is going, passing, and they will detect the size of the cell. So they will detect number of the cell, then volume of the cell, obviously size, and internal content also. So hemoglobin concentration and other things will know with this method. So mainly we have two methods. One is the automated method and manual method, and in automated method we have impedance counters and flow cytometry counter. In flow cytometry we use laser, and impedance we will detect just a pulse. When cell will pass, electrical potential will change, resistance will change, and that will count as a cell. And in case of the flow cytometry counter, we use laser, and with laser we can get the idea about the number of the cell, then volume of the cell means size of the cell, or internal content also, like hemoglobin percentage inside the cell. So let's discuss about the manual counting with hemocytometer box, okay. So let's start. This is the manual method. We must need some instrument, basic instrument. Before going to test, here I want to clear it one more thing, that what is the normal count of RBC. So I am going to discuss about the total RBC count. Total RBC count, that is normal. Normal count is around 4.5 to 5.5 million per cubic millimeter of blood. Cubic millimeter, or we can write millimeter cube. Suppose one cube is there, or one area 1 millimeter in all the direction, means height, length, breadth and height is 1 millimeter, and that volume of blood will contain around 4.5 to 5.5 million RBC. That is also represented as a microliter. Microliter. So this is the same. This is very small volume, or you can say it's a 1000 microliter. 1000 microliter is equal to 1 ml. So we can consider this volume is very small, and that small volume 1000 microliter is, or we can say 1000 millimeter cube is equal to 1 ml, and we are going to count 1 millimeter cube or 1 microliter blood, and that blood will contain 4.5 to 5.5 million RBCs. Okay, so that is the normal range. One more thing here I want to discuss. So 4.5 to 5.5 is the normal range, but in case of female, suppose I'm going to draw this a scale. So suppose this is the 4.5 and this is the 5.5. So this is 5.5 and this is 4.5. So in case of female, count is slightly less. So suppose 4.5 to, suppose this is the female count. Female usually have less count, less than male, and this is suppose this is the male count. Male count usually around 5 to 5.5 million. Male always have higher count. This is for, suppose this is for male and this is for female. Male has slightly higher count and female has slightly lower count, but range is between 4.5 to 5.5 million per cubic millimeter blood. If less than 4.5, then this is called anemia, and more than 5.5, this is called polycythemia. So if more than that, polycythemia, and if less than that 4.5, then we can say anemia. But one more thing I want to discuss here, anemia is not about the RBC count. Actually anemia is about the hemoglobin percentage. So if you want to check anemia, you have to check hemoglobin. So don't get confused. Hemoglobin percentage is the parameter where we can check the anemia. But why I am telling you the anemia? If count of RBC is less, then person may suffer anemia. Why? Because one hemoglobin is always inside the RBC, and how much? This is the, suppose this is the RBC, one cell, and inside this cell we have hemoglobin. How much hemoglobin maximum one cell can carry? Around 33 to 30, suppose. So 1/3 of RBC can be filled maximally with a hemoglobin, not more than that. So one RBC is there, you cannot fill more than 33 or 34% of RBC with hemoglobin. It means if you decrease the number of RBC, so normal RBC count is suppose 5 million, and if your RBC is decreasing and suppose 3 million or 2 million, in that case obviously RBC is full. Whatever RBC you have, number of RBC is less, but whatever RBC you have, suppose that RBC is fully filled with the hemoglobin. Still, if you check the hemoglobin percentage will be lower, because number of RBC is less and hemoglobin will be present in the RBC. So if RBC is less, then number of hemoglobin, percentage of hemoglobin will also down. So that's why if RBC count is less, then it will lead to anemia. That is the main factor here why we can consider also RBC. But first thing, if you want to check anemia, you have to check hemoglobin. If hemoglobin is normal, there is no issue. If hemoglobin is less than normal, then you have to find out the reason. It is iron deficiency, or it because of the RBC count is less. And if RBC count is normal and still person is suffering from anemia, it means it's not filled completely. Suppose this is RBC, and if RBC filled only 20%, it may be iron deficiency anemia. In that case, obviously your count will be normal, 5 million or more than 5 million, but still person will suffer from the anemia. So keep this thing in your mind. So now you know the normal RBC count, but main point I was trying to discuss about the why female has slightly less count than male and why male is slightly more count than female. So only just 2 points. Female has estrogen hormone. One is the menstrual loss, but that is not the main important factor. Most important factor is the estrogen, OESTROGEN. Estrogen hormone has negative impact on RBC production. So estrogen will influence negatively on the production of RBC. So RBC count will be less in case of female, and That's why not only RBC count is less in the female, also hemoglobin percentage is less, because obviously you know the answer why female has less hemoglobin percentage, because RBC count is less than in compared to male. And second one is obviously menstrual loss. Menstrual loss, each and every month menstrual loss will be there, and that because of that there will be anemia. And why male has more count? So this is the less, doesn't mean ki if female has less, male will be more. So male, why male is more? Just because female is less, female has less count of RBC, male cannot increase the number. Yes, because obviously estrogen impact of negative impact of estrogen will not be there, because male has mainly hormone of testosterone. Testosterone have positive impact on RBC production, and that's why male has higher count. And in case of female, we have two negative impact. One is the menstrual loss each and every month of menstrual cycle, and second one is the estrogen hormone. That estrogen hormone also has negative impact. Now we are going to discuss proper RBC count with the manual method, hemocytometer box. So let's start. So let's discuss in details. Compound microscope we need. So this is a compound microscope. Then we need RBC pipette. Where is the RBC pipette? We can see here we have this red color. So here inside this we have RBC pipette. Okay, we'll discuss in details later. Then we have improved Newer's counting chamber. Again, this is improved Newer's counting chamber. Then cover slip. So we are going to use this cover slip, not this one. This one here we are going to use this one. Then pricking apparatus to get blood sample. Yes, we can use a sterile syringe, or we can use the lancet to prick the finger and take out the blood. For that we need the split saw, we can use, or we can use this one also during the for pricking. We can use this instrument for pricking. Next thing, we need RBC diluting fluid, that is called Hams fluid, and sometimes we can use Dace's fluid also. So that fluid is to dilute the RBC. Hams fluid. So first thing, composition of Hams fluid is sodium sulfate, which is also is around 2.5 gram. Then which is also act as anticoagulant. Then second one is sodium chloride in ACl. So this is the isotonicity, maintain fluid to dilute, and isotonicity. Then mercury chloride, so 0.25 gram. This is used at antibacterial, antifungal, antibacterial properties. And then distilled water to make it 100 ml or dilute it. So these are the basic thing we can use, and that is the composition of Hams fluid. Now we have Hams fluid also. Now let's discuss what is the basic principle of this study, RBC count. Principle of RBC count. What is the basic principle of RBC count? So as the number of RBC present in 1 cubic millimeter of blood, it is blood in millions. We have already discussed that RBC count is normal 4.5 to 5.5 million per microliter, or per is in millions per cubic millimeter blood, per 1 cubic millimeter of blood. That is called microliter or per cubic millimeter. 1 microliter, or we can say 1 cubic millimeter, same thing. The blood has to be diluted so that the red cell can be seen distinctly and separately and can be counted. Why? If 1 microliter, which is very very small amount volume, suppose 1 millimeter, just see the scale and see what is the 1 millimeter. It's very very small, like this. This is the 1 millimeter. 1 millimeter is like that. This length, breadth and height, not even this much. This length, weight and height volume will contain around 4.5 to 5.5 million RBC. If we are not going to dilute that and just put under the microscope blood drop, a smaller this volume of blood drop, suppose, so it's almost impossible to count RBC 4.5 million RBC in that particular space. So for that we have to dilute the fluid. How much time? 200 times actually. We have to dilute the blood first 200 times so volume can be counted. So therefore a known volume of blood is diluted 200 times. Okay, and with fluid which is isotonic with blood and prevent coagulation, means that Hems fluid is isotonic with the blood, so cell will not either shrink. If we are going to use hypertonic solution, cell will actually shrink, cell size will be smaller, and if you are going to hypotonic, means then cell will be swell. Hypotonic cell will swell, and that's why we should use normotonic or because isotonic fluid, so cell size will be maintain normal size, cell can maintain their original or normal size. That's why we use isotonic fluid. And then why prevent anticoagulant? Otherwise cell will stick together. Suppose this is one RBC, all the RBC will stick together and counting will be impossible, or roller formation will be there. RBC will be formed like this, a chain type of thing will be formed, and that will be difficult to count RBC. So for that, because RBC count is very high in millions, as the number of RBC present in 1 cubic millimeter of blood is in millions, the 1 cubic millimeter of blood is in millions, the blood has to be diluted first so that the red cell can be seen distinctly, obviously, and separately, and can be counted. For that, therefore, a known volume of blood is diluted 200 times with a fluid which is isotonic with the blood and prevent coagulation. So that is, here we are going to use Hems fluid. Now we are going to discuss in details about the hemocytometer box. This box we can see here is a hemocytometer box. So hemocytometer box, this slide is called Neuwer's slide, improved Neuwer's slide, or hemocytometer slide we can also use term, but use term improved Neuwer's slide or improved Neuwer's slide with counting chamber. Improved Neuwer's counting chamber. So these are the two counting chamber. Here we can see, let me show you, we have here gutter. So two side pillar we have, and then one gutter is here. So two chamber we have here, one chamber and two counting chamber. This is okay, and here depth also mentioned is 0.1 millimeter. Here we depth 0.1 millimeter means what? This side pillar is higher than this central pillar, central platform. Central platform is around 0.1 millimeter, not around, is exactly 0.1 millimeter lower than side pillar. So this side has 0.1 millimeter higher. We can say this side pillar is 0.1 millimeter higher than this central platform, or we can say this central platform is 0.1 millimeter lower than this side platform. Same thing, to accommodate some amount of volume when we'll cover this platform here, this area with the cover slip. If we put something, a glass cover slip here on top of this, then there will be a gap here of 0.1 millimeter, because this central platform is 0.1 millimeter lower than this side platform. Now let's see pipette. So we have two pipette, this is the one pipette and this is the another pipette. Okay, so this you can see that is a red thing, that is actually RBC pipette, and can you see this white here? This is we have white thing, that is called WC pipette. We have both type of pipette here, one is RBC pipette and another one is WC pipette. Here in details we see in this picture, this is, we can easily say that is the RBC pipette with this red bead. This is red bead, and the same thing here we can see WC has white bead. Always you will get the white bead in case of WC and red bead in the white bead in the WC and red bead in case of the RBC. So this is the first differentiating point. We will get two type of pipette, RBC pipette and WBC pipette, how we can differentiate between two. So this differentiating point you will be asked in the practical examination. So first differentiating point is RBC pipette color of bead. So red or white bead. So this is the first point, red bead for RBC pipette, and if bead is white then WBC pipette. Then second differentiating point is marking. Just look at the marking. Here we can say 0.5, here is also we have 0.5, here we have 1, here we have 1, same, but just look at here, we have 101 and 11. So in case of RBC we have 101 marking 0.5, 1 and 101 in case of RBC, and WBC 0.5, then 1 and then 11. So this is the WBC and this is the RBC. So first differentiating point, bead. So bead is red in color in case of RBC, bead in white in color in case of WBC. Second differentiating point is markings. So in case of RBC pipette we have marking 0.5, 1 and 101 RBC, then 0.5, 1 and 11 in case of WBC pipette. And sometime, and one more thing we can say, consider this bulb size. In case of WBC, bulb size is smaller because dilution we need in case of WBC counting is only 20 times. So that's why we need a smaller bulb. And in case of RBC, we have already discussed in the principle that RBC dilution is 200 times. 200 times we have to dilute the blood. So that's why bead bulb should be bigger. So that is another differentiating point, bulb size. Bulb size, but this is the comparative size. If you have both RBC and WBC pipette, and then you can compare, okay, this bulb size is smaller in case of WBC and RBC bulb size is bigger. One more thing we can say here, this mouthpiece in RBC we always see the red. Here we can see the red. This is the RBC. See, this is the RBC, red bead, and this mouthpiece is also red in color. Here we can see the WBC pipette and this mouthpiece also white in color. So that is also we can consider. So here we can easily see the RBC pipette and WBC pipette. And improved newer slide. This is a thick, very thick slide that is called improved newer slide. And next thing we are going to show you cover slip. This is the cover slip which is used to cover that glass slide. Which glass slide? Newer slide. And let's discuss about a newer slide in details. So we have already discussed something about newer slide, but just see here. This is the newer slide. This is a thick slide. This is also newer slide. This is a picture. And here I have already told you there is a gap. This is a side platform. This is the cover slip. You can see the cover slip. See here, this has cover slip. This is cover slip, and here you can say this is the cover slip. Okay, this is the cover slip. Clear? And this side platform is 0.1 millimeter higher. 0.1 millimeter is higher. See, this is higher than this platform. So this is 0.1 millimeter lower. Okay, there is a gap of 0.1 millimeter here, we can see, because of this side pillar is higher than this center platform. And here is the center platform. This is the two counting area. This is the two platform, and this is the counting area. And this counting area length is 3 millimeter. 3 millimeter. So this whole area 3 millimeter into 3 millimeter. So 3 into 3 millimeter. 3 into 3 millimeter into 0.1 millimeter. Actually volume, if you want to consider whole area, and this whole area volume 3 millimeter, length 3 millimeter, breadth, and height is 0.1 millimeter, because there is a gap of 0.1 millimeter. So because of that we will get, here we see this 3 millimeter. I am talking about this 3 millimeter is here under the microscope. Just see this area. This is actually 3 millimeter. 1 millimeter, then 1 millimeter, and then 1 millimeter. So this whole area from here to here 3 millimeter. So if you put under this area under microscope, this will look like this, and under the microscope real picture you just see, compare with this one. Here in this picture, this is the 1 millimeter, 1 millimeter, and 1 millimeter. This complete area is 3 millimeter. The same thing here in the drawing, and this is the actual microscopic picture under 4x magnification objective lens. I am talking about the 4x objective lens. Total magnification, if you see 4x we use, then 4x into 10, so total magnification will be 40x. How 40x? Total magnification 40 time magnifying. We are going to put this slide under the microscope and magnifying max total magnification is 40 times. How? We are going to use objective lens with 4x power. With details microscope, you just learn about the microscope in details, but simply I am explaining 4x objective lens, and 10x is eyepiece. Eyepiece is most of the time fixed 10x, so 4 into 10 is 40x. So total magnification will be 40x, and in 40x your this area chamber will be look like this. So I am cleaning it. 40x, this area, if you magnify 40 times, then it will look like this, and this area length is 3 millimeter, breadth is 3 millimeter, and obviously height gap is 0.1 millimeter. So obviously same thing here, we can see the same thing, 1 millimeter, 1 millimeter, 1 millimeter, and 1 millimeter, 1 millimeter, and 1 millimeter. This area is WBC counting area, this 4 area is WBC counting area in that, and this is a RBC counting area. So this is the RBC counting area. Here you can say this RBC counting area, and this 4 is 1, 2, 3, 4 is WBC counting area. Okay, so WBC counting area is the 1 millimeter into 1 millimeter into 4, 1, 2, 3, 4. Okay, and RBC counting area is total actually this 1 millimeter length and 1 millimeter width, and we are not going to count as a whole this box. So we'll discuss again in details later. For now we understood the newer slide, how newer slide look under the magnification when we magnify it under the microscope. So this is the 40x magnification. So we are discussing about the RBC counting. Counting first, we'll discuss about the RBC counting. So RBC counting is done in this area, so let's magnify this area more. Okay, this area, sorry, yeah. So we are going to magnify this area in details. So how will magnify this area? So let's magnify. How much magnification? This one was 40x total magnification, which will magnification of this area 40 times 40x, it will look like this, whole thing will be appear. And when we magnify more, how much magnification? It's the 10 into 10 is equal to 10 means 10 is objective lens and 10 is eyepiece. So total magnification is 100 times. When we magnify this chamber 100 times, then it will look like this. So this magnification is this is the 100x magnification of this area. How much? 100x. Let's see 100x. Here we can see 1, 2, 3, 4, 5. Then again 1, 2, 3, 4, 5. So 5 into 5. This 1 millimeter area has 5 into 5. Let's count here. 1, 2, 3, 4, 5. Yes. 1, 2, 3, 4, 5. But in case of WBC, see 1, 2, 3, 4. 1, 2, 3, 4. Only 4 into 4. But here the same area, 1 millimeter area here, and into 1 millimeter we have 4 into 4 and single lining. Here we have 5 into 5. So that must be clear. And the center we have RBC counting area in the center. Up to now we have cleared that this is the 40x magnification. We'll see the whole newer slide, whole 3 millimeter into 3 millimeter area. When we magnify it more 100x, then we see only the RBC or only the WBC area. So if we change the focus, we can just magnify this area also when we are going to count the WBC. So now we are discussing about the RBC, so that's why we are focusing RBC area. Hence 100x magnification will focus the 1 millimeter into 1 millimeter area clearly. It may be RBC counting area or it may be any WBC counting area, any area you can focus. But WBC counting will be done in the 10x magnification, but we are going to count RBC. So for RBC we need the 100x magnification. Counting will be done in the 100 WBC counting will be done in the 10x. So we will focus in this magnification, 10x magnification. Just slide will focus not under the RBC area, but will focus in the WBC focus area under the 100x magnification, total magnification. But RBC counting we will do in the 40x magnification. Total magnification 40 into 10 बराबर 400x. It means it will focus this area in the larger. So let's see how it will look like. This area we are going to count. RBC counting will be done only in the 1, 2, 3, 4 and this 5 area. We are not going to count this whole area RBC. First we will charge it and then count it. For WBC we are going to count this and this whole all area. But in case of RBC counting we are going to count focus in this area, but not as a whole this area, but we are going to count a 5 area, 1, 2, 3, 4 corner and 1 center. So only 5 area. Out of 25 boxes we are going to count only 5 boxes. And let's see the 5 boxes, how these 5 boxes will look like. So we are going to focus, this is the 40x. So when magnify 400x, so total magnification will be 400x. This one area or any one area will be look like this. Understood? And here we can see the lining is 1, 2 and 3 lining we have. Here we have 1, 2, 3 lining. Here we have 1, 2, 3, 1, 2, 3. So we have different linings. Magnification, this is 40x total, this is 100x total, this is the 400x of this area. Clear? Here we have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 and we are going to focus one area. So this one area, inside this one area we have 1, 2, 3, 4, 1, 2, 3, 4. Okay. Let's recap one more thing here. So this length is actually 1 millimeter and this 1 millimeter and 1 millimeter is divided under the 1, 2, 3, 4, 1, 2, 3, 4 and 5 area. So area of this means this area will be, this whole area is 1 millimeter. This is important actually. So we have divided into 1, 2, 3, 4 and 5 area. So length of this area is 1 by 5 millimeter. This whole length is 1 millimeter and this length is 1 millimeter, 1 by 5 millimeter. So 1 by 5 millimeter. This area is 1 by 5 millimeter, not 1 millimeter. This area is 1 by 5 millimeter, 1/5 of 1 millimeter. And breadth is also 1 millimeter, 1 by 5 millimeter. So this area is also 1 by 5 millimeter. So 1 by 5, 1 by 5. So 1 by 5 into 1 by 5. This is the area of one box. This one box area has 1 by 5 millimeter into 1 by 5 millimeter, because this whole area is 1 millimeter. That's why this smaller area is 1 by 5 millimeter into 1 by 5 millimeter. And we are going to count 1, 2, 3, 4 and 5 area. 1, 2, 3, 4, 5. So if we are going to calculate the volume of this 5 area, will be 1 by 5 millimeter into 1 by 5 millimeter into 5, because we are going to 5. 1 by 5 into 1 by 5 means one box area, and we are going to count 5 boxes. So 1 by 5 into 1 by 5 into 5 area into, if we will, this is the area. to calculate the area 1 by 5 into 1 by 5 into 5 boxes. So total area we are going to count, we can calculate. Okay, but if we want to calculate the volume of that particular 1 2 3 4 5 area, then we have to add 1 by 10 millimeter this depth also, 1 by 10. So totally 1 by 5 into 1 by 5 is 1 by 25 into 5, 1 by 250 into 1 by 10. So finally we'll get the 1 by 50. Area will be 1 by 250 into 1 by 10. So finally we'll get the 1 by 50 millimeter cube. So mm cube, or we can say 1 by 50 microliter. 1 by 50 millimeter cube volume will get in this 5 boxes. We have volume 1 by 50 microliter or millimeter cube volume. So how volume is calculated? Again I am going to repeat this volume once more, because volume is very important. As we know, this area, whole area is 3 millimeter, this whole area is 1 millimeter, this whole area is 1 millimeter, and so if 1 millimeter is this whole area, if we divide into 1 2 3 4 5, so one area from here to here is 1 by 5 millimeter. So just write 1 by 5 millimeter. So this length, breadth will also same, into 1 by 5 millimeter. So if we calculate this area, so 1 by 25 millimeter. So area of this small box, okay, this one box, or we can say this small box area is 1 by 5 into 1 by 5, so 1 by 25 millimeter area. Okay, but during the RBC count we are going to consider 1 2 3 4 and 5 area. So total area we are going to count in case of RBC, not WBC. In case of RBC we are going to count 1 2 3 4 5 area. So one area, one box area is 1 by 25 millimeter. So 5 box area will be 1 by okay, okay, area of this whole is, this whole area is 3 millimeter, this area is 1 millimeter, this area is 1 millimeter, and this one area is 1 by 5 millimeter, because this whole area is 1 millimeter. So this smaller area will be one side 1 by 5 millimeter. Same thing here, 1 by 5 millimeter, 1 by 5 millimeter. So 1 by 5 into 1 by 5 millimeter. So if you want to calculate the volume of this area, so 1 by 5 millimeter into 1 by 5 millimeter, area we can calculate. So 1 by 25 millimeter is equal to 1 by 25 millimeter. So area into volume, we know the 0.1 millimeter, or we can say 1 by 10 millimeter into 1 by 10. So 1 by 250 millimeter, and into so 1 by 5 into 1 by 5, 1 by 5 into 1 by 5 millimeter. So just remove this 1 by 5 into 1 by 5 millimeter. So I am going to discuss about the volume of this area, 1 by 5 into 1 by 5 millimeter into 1 by 10, 1 by 10, because the depth is 1 by 10 millimeter, 0.1 millimeter or 1 by 10 millimeter. So volume of this area we can calculate 1 by 5 into 1 by 5 into 1 by 10 millimeter, okay, and into 5, because we are going to count 5 this type of box, 1 2 3 4 5. So total volume we are going to count will be, if we calculate, then 1 by 50. So if after calculation 1 by 50 microliter will get 1 by 50 microliter. Why? Length 1 by 5 millimeter, breadth is 1 by 5 millimeter. So 1 by 5 into 1 by 5, obviously volume. So height is 1 by 10 millimeter height. So gap is 1 by 10 millimeter, or we can say 0.1 millimeter. So we can consider 1 by 10. So volume of this one box will be considered. One box will get, and we are going to count 5 box. So 5 box into 5, when we'll do this 5, then we'll get the total volume after calculation will be 1 by 50 microliter, or 1 by 50 millimeter cube. So that will be the volume of 5 boxes. Total area we are going to count the volume of that total area. And dilution factor, just remember dilution factor is 200 times, so that's why into 200 will be helped to do. So that we'll discuss later. So now we'll move how to do the test, and then we'll discuss calculation part later. Maintaining all the aseptic and antiseptic condition, we are going to collect blood from a sample of blood, and then we'll count total RBC. Okay, so we can also prick a finger and take out the blood, and we can do the test, but here we are going to collect the blood in the vial, and then we'll do the test. We have already used the speed soap to clean the area, and we have to wait for the complete dry, and then we can draw the blood. A sterile needle we can use, or a sterile syringe we are going to use to draw blood. Let's see. Yeah, blood is coming. You can see here, this area, this blood is coming. And all the superficial prominent veins, we can see this is a prominent vein. So because it's easier to get blood from the prominent vein. Now it's done. So speed soap we are going to use. Yes, so done. We have collected the blood sample. Now we should open the tourniquet and put this blood to the vial. So this vial is actually contain anticoagulant to prevent clotting, and here we should be very careful to put the or transfer the blood from the syringe to the vial slowly. If you will get the vacuum vial, then blood will go automatically. You don't have to push. Okay, blood will go automatically with the vacuum. But here this vial is not vacuum vial, so we are pushing the vial. But here we should be very careful to put slowly, otherwise blood cell will rupture. If we press it so forcefully, if you transfer the blood with force, then blood cells will get ruptured. So we should transfer blood very slowly. So that should be precaution. And now we have to move once or twice up and down to mix the blood with the anticoagulant. So blood should not coagulate, or so I am mixing it just while slowly moving the tube. Now we are ready with the blood to do the test proper. I am mixing in, so blood should not get coagulated. We are going to start the procedure of RBC counting, total RBC count. So I am going to take RBC pipette. This RBC pipette must be clean and dry. Then improved Newer's slide, WBC, and this slide and all the instruments should be very clean and dry. So make sure wash it with the soap and water. Newer's slide and pipette should be completely dry and clean before going to use. we should ready with all the instrument before going to perform the test. So this is the microscope. This area is actually have condenser. So this is the stage and this is the sub stage, you can say, and this is the light source, and this is the fine and coarse adjustment. So inner side we have coarse adjustment and outer side we have fine adjustment. Okay, and this is the light source, and this sub stage condense diaphragm and condenser. This is a condenser and diaphragm is here, so one opening is there, and that opening we can close or open. And here we can see the under the microscope, this is in your slide, this is one area. So I am using the 4S objective lens, and this is the WBC counting area. See, 1 2 3 4 box into 1 2 3 4, and this box is in corner, upper left corner, and this is the second WBC chamber, and actually this one is actually RBC counting area. This is not focused properly. 1 2 3 4 and 5, 1 2 3 4 5, 1 2 3 4 5, and this side you will get another WBC area. This is the another WBC counting area, and here you will get the another WBC counting area. So these are the WBC, WBC, WBC and WBC, and this is the RBC. Here we are going to count this 1 2 3 4 and this 5 area. So 5 RBC area we are going to count for WBC count. Now let's see. Okay, this is the WBC pipette and this is the RBC pipette. We can see markings are not clear, but RBC pipette has red bead and WBC pipette has white bead and white mouthpiece. And bulb size, we can see comparatively bulb size is smaller in case of WBC and bigger bulb size in RBC. So let's start the test properly. Yeah, now let's start the blood. This is the RBC pipette and we are drawing the blood. So before that we must okay, so I am drawing a pipette. This is the pipette. Okay, this is the bulb, this is the bulb. Okay, and here we have red bead. Okay, here we have 0.5, then 1 and then 101, 3 marking, must remember. So first what we can do, we will take blood. So first we will take blood. How much blood? We will take 0.5 blood. If by mistake we will take extra amount of blood, suppose, then what we can do, we will put we will take a slide or any hard surface. We should not put cotton. If you put cotton on the tip, only fluid part will come out and cell will remain there and your count will be higher, because any absorbent material will take out only fluid part from this blood. So final volume we will see, okay, 0.5 is there, but only fluid part will come out with the cotton. So we should not use cotton at the tip to take out the extra blood. So what we can do, we should take a hard surface, any hard surface or glass slide, and tap the tip of this pipette and take out extra blood, and you will get the final volume of 0.5. Make it 0.5. Done. So first volume 0.5. Now you should, again, what you can do, we can take diluting fluid. Which diluting fluid? Suppose this is the diluting fluid. Okay, put your pipette, RBC pipette in the diluting fluid and take the diluting fluid. So what will happen? Diluting, you are taking taking diluting fluid. So how much diluting fluid? To cover it. So diluting, if you start taking diluting fluid, so this diluting fluid actually push the blood 0.5 where? Towards in the center. So blood will push here. So 0.5 blood will be go in the bulb, and then it will be filled with the diluting fluid. So up to this, and this whole bulb will be filled. So this bulb contain 0.5. This bulb part will contain what now? 0.5 blood, 0.5 blood, and rest diluting fluid. Okay, and this up to one, this part will contain only diluting fluid. So here dilution factor, how will you calculate dilution factor in this particle? So this final marking is 101. So 101 is the final marking minus 1. Why we can -1 because this part up to this part only carries diluting fluid, no blood is there, so we have to minus that part. So final volume will be 100. So final volume will be 100 and initial volume was 0.5 blood was there. Remember 0.5 was blood, 0.5. So initial volume blood is 0.5 and the final volume 101 minus 1, 101 minus 1, 101 because this is the 101 and minus 1 is the stem part. So 101 minus 1 is the 100. So final volume will be 100 and out of that 100 we have only 0.5 blood and rest is fluid. So dilution factor if we want to calculate, so final volume divided by initial volume, so it will be 200 times. Clear? So here few precautions we have to keep in mind. One thing, while taking the blood we should take exactly 0.5 blood. If by mistake we are taking extra blood by mistakenly, so we should not use cotton to take out extra blood. We should always tap on the hard surface to take out extra blood. Make sure, otherwise cotton will only take out the fluid and cell will remain there and your count will be higher than actual number. One thing. Second thing, while taking blood, make sure there should be no air bubble in between the blood. So if you putting the air bubble in between the blood, then your count will be lower count will be lower than actual. Then second thing, if extra blood is present outside, so just wrap cotton wrap around the pipette and take out all the extra blood without touching the tip. Then you should take the diluting fluid which mark up to 101 mark. So procedure will be done. So we have already taken the blood, extra blood is sticking on the outside the, so we should just wrap around the and in one go just take it out, extra blood. Just wrap without wrap the cotton outside the and pull downward in one go, and if extra blood is there, as we can see here extra blood is there, so I am tapping this extra blood out, not putting the cotton. I have already explained why cotton we should not use. So tap it and take out. So now it's done. It's done. Now we have only 0.5 blood in the pipette. Extra blood we have already taken out. So now we'll take what? Diluting fluid. Now we are going ready for take diluting fluid. So this is the RBC diluting fluid. This is the RBC diluting fluid and I am taking the fluid. So here one thing is you must know. So while putting diluting fluid, your pipette should be at the angle of 45 or vertical. Initially you can keep it your pipette 45 degree and slowly gradually you should put your pipette vertically, otherwise air bubble will be you will get air bubble trapped inside the pipette and this bulb area. So to avoid that, always draw this is exactly 0.101 mark. Okay, so that should be careful. Let me explain the main thing here. So now I am going to mix it. So I am again explaining one more thing. While taking the fluid, your pipette should be vertical. If you tilt the pipette in the 45 degree or less than 45 degree, so what will happen? In the bulb part, some air will trap and your counting will be higher. Why higher? Because you are taking less fluid. Instead of fluid, you are taking the air bubble, so that your count will be higher. If you put the air bubble in between the blood, so we are going to take 0.5 blood, and in 0.5 blood if we have the air bubble, then your count will be lower. So now I am going to mix it. So everything is ready. Up to 101 blood is there. A stem part we have only fluid and blood is already pushed towards the bulb, and in the bulb we have blood as well as fluid, and a stem part we have only fluid. So that you should keep in mind. A red bead will actually help you to mix the blood with the. Now we are ready with the slide and we are putting the this cover slip and just cleaning the cover slip with the dry cotton to remove any dirt present there. and it's hot clean. Now this is the thick cover slip on the newer slide. So I'm going, and here side pillar is higher than that central pillar, 0.1 millimeter. So if we'll put this cover slip, there will be gap between the cover slip and the central counting area. So there will be a gap, and that gap will fill with this fluid, whatever we have prepared now, after discarding the stem part. So first we'll discard the stem part and we'll fill this area. Both side we can fill, or any one side we can fill, or sometime we can use one side for RBC and other side for WBC also. But here we are going to fill this gap of 0.1 millimeter with that prepared fluid. And how we'll charge it? So let me show you how to charge it. So this is the pipette, and here we can see easily one thing. So there is this cover slip and this slide. So we will make, what we can do, this suppose this is pipette, and we'll make a smaller drop on the tip of pipette. So RBC pipette we have prepared. So first discard few drop of fluid, because stem part only carries the fluid and no cells, so we have to discard few drop. After dilution everything is done, and after discarding few drop, so make a smaller drop at the tip of the pipette and put that pipette in between this here. So here you have to touch, just here you have to touch, where? Between the cover slip and the slide. Slide means platform, newer slide and cover slip. So this angle of this newer slide and cover slip touch with that angle, and automatically this blood drop will go inside this whole area by the means of capillary action. So capillary action will actually pull the fluid inside the chamber, and the chamber will fill. And make sure that it should be not overcharged or undercharged. So in both the condition, your count will be lower. Decrease count will be lower. Both undercharged, obviously undercharged, you are charging the not full area is not charged, you are charging less area, so obviously count will be lower. But even if you are counting more, if you are overflowing this area because excess fluid you are putting, so in that case also your count will be lower. How it's possible? Yes, it's possible because cells are heavier. Which cell? Actually I am talking about the RBC cells are heavier. So if you put the excess blood, so fluid will come out from this counting area to the gutter. So here we have side gutter, and with the fluid, because cells are heavier, so fluid, more number of cells will come down to the gutter, and you will left with a less number of cell in the platform itself. And more the cell, because the cells are heavier, it will go to the gutter side, and because of that your count will be lower. So in the both condition, if you charge overcharged, again your count will be lower. Undercharged, obviously you are charging under, so count will be lower. So in the both condition your count will be lower. So let's move to the next part. So I'm going to charge now. Yes, so I'm going to discard the stem part of fluid now. Stem part, as the stem part only carries the fluid. 101 minus 1, so total volume will be, final volume will be 100, and divided by 0.5, as initial volume was 0.5 of blood. So 100 divided by 0.5, so you will get the total dilution factor will be 200 times. So now I am going to discard that stem part. So by tapping I am discarding it. So few drop we have to discard. So now I am going to charge it. So make sure you should make after discarding up to a stem part 1, and we are making a small drop at the tip, and see fluid is going by capillary action inside this. So it's going, it's done, charging is already done. We can see here fluid is here in between the cover slip and glass slide. There is a gap of 0.1 millimeter, and within that gap we have filled with the diluted fluid from the bulb area. And now we are going to focus. So first we will focus under the 4x objective lens, or 4x. So we'll see the bigger picture, and then finally we are going to count 10x and then 40x. RBC counting will be done in the 40x. So 40x means total magnification will be into 10. 40 means objective lens and 10 is the eyepiece. So total magnification will be 400x. So learn microscope in details. So this is I am moving the slide left and right or forward backward to focus, bring under the microscope directly. So first focus the area and then use the coarse adjustment first to see the cell as clear as possible, and then use fine adjustment to make it more clear or visible. So first we should screen the cell with the lower magnification. So 4x or 10x objective lens we can use, and then finally we will count RBC under the 40x. So see, the cell is visible here. Yes, wow, nice cell. So we can see, wow, these are the cells and these are the triple lines. So see, these are the 1, 2 and triple line, and these are the RBCs. Yes, very, very clear. So these are RBCs. So let me tell you, these are the cells. See, RBC will fill with hemoglobin. These are the RBC actually. RBCs. These are RBCs. These all are RBCs. It's very clear. Very, very clear. So let me focus it. So let's, this RBC is focused, and we can see this is one RBC counting area. We can see this is one RBC counting area, this is another RBC counting area, because triple line is here, and this is a triple line, this is triple line, this is triple line, this is triple line. So these are the actually RBC counting area. So different RBC counting area, and we know this is a 40x actually. Now this is actually 10x. So that's why we can see the bigger area. See, I am focusing under the microscope. Yes, let's see how it's look like. Yes, that's good. Yeah, that's one RBC counting area. So this is the one RBC counting area. We have to count 5 this type of area. So this length is 1/5 millimeter from here to here, because RBC counting area, this is RBC counting area, whole area is 1 millimeter. So we have divided into 1, 2, 3, 5 area. 1, 2, 3, 4, 5 area. So we are going to count 1, 2, 3, 4, and suppose this is the and 5. So this area we are focusing here, this area, okay, and this area has a triple line. Inside this area we have 1, 2, 3, 4. So another 4 lines. So let's color 1, 2. So 1, 2, 3, 4. 4 into 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So 5 box we are going to count 1, 2, 3, 4, and 5 area. Here one more thing, I am again repeating the calculation, which is very, very important, and then I will tell you how to count it. So counting is very, very important. First, volume. So volume of this one box. So we know this area is, total area is 1 millimeter, and this area is 1/5 millimeter, obviously 5 times divided. So 1/5 this area. So this area is 1/5 millimeter, and obviously this area is also 1/5 into 1/5. Okay, and we know the cover slip and the slide we have gap of 1 by 10 millimeter. So volume is the length, breadth and height. So length is 1 by 5 millimeter, breadth is 1 by 5 millimeter, into height is 1 by 10 millimeter. So that will give you the volume of one box. So this volume of one box is 1 by 5 into 1 by 5 into 10, and we are going to count 1, 2, 3, 4 and 5 box. So into 5, and then you will get the total volume of that area what we are going to count. Okay, so now before going to counting, you make some box of 5, this type of box. This is one box, and make the similar type of 5 box. So no, not this similar type of box, you have to make this 5 box. So how will you make 5 box? Suppose 1, 2, 3, 4, 1, 2, 3. So now you have to make 5 this type of box, this type of 5 box. Okay, for counting. So make sure you have 5 boxes. So suppose we are showing this in the microscope. How much magnification we need? 40 into 10. 10 is the eyepiece and 40 is the objective lens. Total magnification is 400x. You will get this type of focus. Okay, so let's start the counting. So how we can count? So here one most important thing about the triple line is very, very important. So we have triple line here, here, here and here. Okay, so triple line, middle line should be reference line. I am telling you the middle line should be reference line, and left and upper. So upper and left, any cell touching the upper and left middle line, we will consider the cell inside the box. Okay, and with the same formula, if the cell is touching middle line to the right and lower, then we will consider the cell in the outside, or we can say next. Why this is next? Because just I am explaining. Suppose we are going to count all the cells. Suppose this is the first cell. This is actually not clean, that's why I am showing it. So suppose this box is actually this one. Okay, and if suppose we are going to count this box, all the 5 box. Why we are going to count only 5 box randomly, 4 corner and 1 center? Because if we start counting all 25 box, we can do that. There is no problem and no harm to count all 25 boxes. But problem is that RBC count is in very high millions, so it will be very time consuming, will take lots of time, and that is not possible in the lab. So it will take lots of time and money. So that's why what we can do, we can take 4 corner. Why 4 corner? Not continuously 5 box, because 4 corner, then suppose you are during the charging, one area has more RBCs, another area has less RBC. One area has more RBC, another area has less RBC. So in that case, if you will take the 4 corner and 1 center, so you will get the average picture of all. Okay, so clear? So we can count all 25 box, but we are going to count only 5 boxes because it will take lots of time. Okay, then why we are going to count 4 corner and 1 center? Because if we will count in one area, one side, so suppose while charging, this is manual procedure and this is not that accurate. So if suppose mixing is not proper, or one side have more cells and another side is less cell, that's why we are taking all the 4 area, 4 corner and center, so you will get average picture. Okay, that much clear? And now the thing is that central line is a reference line. So we have this, all the lines are central line, triple line. This all the triple line we have, and inside that we have 4 lines, 16 line. So we are not going to discuss about that line now. We are actually discussing about the triple line. So we have triple line here, we have triple line here, and suppose by chance we are going to count all the cells, all the 25 cells. So considering central or middle line, the reference line, so any cell touching the left and upper border of this central line, suppose this cell will go inside, this cell will go inside, this cell will go inside, this cell will go outside, because this is already not touching the, but this cell is touching middle line. So any cell touching middle line from any side, from outside or inside, it will go inside. Suppose this cell is touching, so it will count inside, and this cell we obviously count because this is already inside. But here with the same formula, this cell is touching, suppose this cell is touching middle line, so it should go in this cell and not here. But we are not counting all 25 cells, but ideally if you count, so this will go into this box. because this is the left of this box. This right of this box is actually left of the next box. So we should exclude, or we can say this cell should go in the next box. And same thing lower, this cell should be go in the lower box, any cell. Even if your this cell is from inside, this cell is actually inside, but this cell is touching the middle line, with the same formula we should use, and we should keep this cell in the next box, because this is the upper of this box, second box or lower box, upper. So we have already told you, I have already told you that upper and left we have to consider. Middle line is a reference line, and any cell touching the upper and left, middle line of the upper and left, we should consider that cell inside. So here we should consider that upper and left here, and the same formula in this midline. If touching any cell from any side, from inside also, we have to consider next cell. And that's why we have to discard that cell, because we are not going to count continuously all 25 cell, but formula remains same. Otherwise you will count extra cell. If you consider this, okay, outside this cell touching middle line, we will consider here, and this cell is also touching here because it's looking like more here, so we'll count here. Then your count will be higher. Ideally it should go in the next box, and right is the next box, because right is actually left of the next box, and upper is the lower is the actually upper of the next box. Clear? So left and upper we have to consider, and right and lower we should discard. Why discard? Because I think now you are clear about all the things. So again I am repeating, left middle line is the reference line, left and upper we should consider inside the box, and with the same formula right and lower we will consider in the left box. Even cell from inside, if this cell is touching from inside also, like this cell is touching from inside, then again you should consider this cell is the next box. And as we are not going to count next box, then it's okay, but you should not include this cell here. Actually we should consider this cell here, this cell here, and any cell from inside or outside, any cell touching the midline. Just make a your reference should be clear. So same, your formula should be fixed. So middle line is the reference line, any cell touching the middle line of the left and upper, you have to include it. And the same formula, if any cell touching the middle and lower, right and lower, we should consider outside. So that should be clear. Now let's move to the next part, counting part. Here we have cell, so let's start counting. So we have to make 5 boxes here. So each boxes, suppose this is the one, this is a triple line boxes, this box. So here we have to make 1 2 3 4, and suppose this is the first box. So here we middle line is the reference line, so this cell is touching middle line, so we'll count 1 1 2 3 4 5 6 7, and we can consider 8. So suppose 8 is here. Okay, so next box 1 2 3 4 5 6 7 8 9, so 9 we can count here. So likewise, and this one also we can consider. If you are thinking that this is the middle line touching the middle line, when you will see in the microscope, use the fine adjustment and you will get idea. So because this is a picture, it's not clear, so that's why I'm considering it that this is a maybe or may not be, but this cell is actually go here. This cell will go in the center. 1 2 3 4 5 6, like that we go 1 2 3 4 5, and then count, and then total you will get the number, suppose 50 in this box. Then this is the left upper, suppose this is this box. So now we will count the next box, second box. This is the first box, second box, then third box, then fourth box, and then fifth box. Suppose first box 50, then second box is suppose 60, this box is 60. Total count, after total count will be 60. Then suppose here also 50, so 60 plus 50 plus 60 plus 50, suppose. So you will get 55, 120 and 220. So suppose this is a 220 cells. Okay, into we have to do 10,000. and then you will get the total number. Why 10,000? 10,000x. So whatever cell you will get in all total 1 2 3 4 5 boxes, just simply do into 10,000x and you will get the actual number of the RBC count. So that calculation now we'll learn. So why we should do 10,000x, that is important. But this 10,000, with this 10,000 you must remember one thing, why I told you that middle line is reference line, and this is so important to count each and every cell. If you are counting one extra cell, it means you are counting 10,000 extra cell, because after counting you have to multiply it with the 10,000. So if you are counting one extra cell, you are multiplying the final number. Suppose now your cell count is 220, and if you are counting one extra cell, so it will be 221, and into 10,000 if you do so, your cell will reflect, final number will reflect like a 10,000 extra cell. And if you count one less cell, then your count will be 10,000 cell less. Because of this reason, because we are going to multiply it by 10,000. So why we are going to multiply it by 10,000, that we'll discuss. Now we are clear. This is the one box, and in one box we have multiple cells, and total number is suppose 50. Now next box we have another box, then we have another box, we have another box, and then one box. So 50 50, and total number is, suppose you are getting 500. Suppose 1 2 3 4 5, suppose this is 100 100, suppose 100 100 and 100, and total number will be 1 2 3 4 5. And one thing, if you are counting one extra cell, counting I already told you importance of triple line. Left and upper should be include any cell touching the left and upper middle line. The middle line is a reference line. Any cell touching the upper and left border of the middle line, then you should include inside the box. And with the same formula, if any cell touching the right and lower line of the middle line, so you should consider the left next cell, or discard it, because we are not going to count next cell, but we should fix with the formula. Why we should fix with the formula? Because final number is 500, then we should count 500 into, suppose 500 is final number, so 500 into 10,000. So if you get 5 million, suppose, so final number. So if you are counting one extra cell, so if you are 501, then your counting will be 10,000 extra cell. And if you are counting one cell less or 10 cell less, then each and every cell will reflect as a final number with the 10,000 decreased or increased number. So that's why we should be very very careful while counting, and carefully we should consider triple line. Okay, but why we are doing this 10,000x? 10,000. Why? First thing, RBC count we know the 4.5 to 5.5 million now per millimeter cube, or per microliter of blood. Yes or no? So this count is actually represented in the millimeter cube or microliter. Okay, but please remember the volume. So what volume we got? 1 by 50 microliter. Total counting is done in the 1 by 50 microliter blood, not whole blood, because we are going to count this type of area. So this area has 1 by 5 millimeter length and 1 by 5. So again I am counting this area. Okay, so this area is actually 1 by 5 millimeter, and this area is also into 1 by 5 millimeter. Okay, so this is length into height is 1 by 10. So volume of this area will be this much if you calculate this, and we are going to count 5 this type of box, 1 2 3 4 and 5 box. So into 5, so 1 by 5 into 1 by 5, 1 by 5 into 1 by 5 into 1 by 10, because volume and gap is 1 by 10, into 5 box. So total volume will get the 1 by 5 microliter, and this is not 1 microliter on 1 by 5, 50 microliter or 1 by 50 millimeter cube. That volume we are going to count cell, and in this volume if you are getting 500 cells, suppose all you have counted all the 5 boxes, and you got 500 cells. So you got 500 cell in 1 by 50 microliter blood or 1 by 50 millimeter cube of blood, and that is very less than 1 cubic millimeter of blood. Yes or no? So first we have to convert it to 1 millimeter cube or 1 microliter blood. So that's why we have to multiply with the 50, and that represent in the whole blood. But here we have already diluted blood 200 times. So 200 into 50, because 200 is dilution factor. To make it whole blood, convert it to the whole blood, because whatever we have counted, we got 500 cell in diluted blood, not in whole blood, but final number should be in the whole blood. So for that dilution factor we have to adjust, and into 200 we have to do, as because dilution is 200 times. And here total volume of total number of RBC is represented in the per microliter or per millimeter cube, but here we are not going to count 1 microliter even, very less. So for that we have to do 1 by 50 microliter we are going to count volume, and that volume is not whole blood but diluted blood. So for dilution factor we have to adjust 200, and to volume convert it into 1 microliter blood we have to into 50, so we will get 10,000 x. And that's why whatever number we will get, the 500 or 100 into 10,000 we will do, and then we will get the total number. So that should be the final number. Calculation A, calculation of dilution factor. So dilution factor, we know that we are using the 0.5 blood, then final volume will be 101 after taking the diluting fluid, then bulk part will contain 0.5 blood and diluting fluid, and stem part will contain only fluid part. So we have to discard 101 minus 1, so we will get with the 100 divided by initial volume, stem part will be 0.5, so total dilution factor will be 200 times. So that is 200 times is the dilution factor. Then calculation of volume of fluid examine. So how much fluid we have examined in the 5 boxes, 1, 2, 3, 4 and 5 boxes. So total volume but 1 by 50 microliter, 1 by 50 microliter or millimeter cube. So that is very less blood than that 1 millimeter cube or 1 microliter. So area of 5 medium size square is 5 into 1 by 5 millimeter into 1 by 5 millimeter. So 1 by 5 square millimeter, and depth is 1 by 10 millimeter. Hence volume of fluid over 5 RBC square is 1 by 5 square millimeter W times into, so 1 by 50 microliter. So 5 square 1 by 50 microliter volume we are going to count, and not 1 microliter. C, calculation of the total RBC count. Let n to be total number of RBC. Suppose you are getting all the 5 boxes you have counted, and you got 500 cells. Okay, counted 5 medium size 1 by into in 1 by 5 microliter of blood. So whatever cell you got, that is in 1 by 50 microliter of diluted blood. So therefore the number of RBC in 1 microliter of undiluted blood will be 50 times dilution factor into 200 times, 50 times. So to convert the volume, so here to convert into 50 we have to do to convert volume into 1 microliter and dilution factor 200 times. So total volume will get the 250 into 200 dilution factor, so we'll get the 10,000. So total cell n into 10,000. So you will get the total number. So suppose you are getting the 500 cell in the 5 boxes into 10,000. So you will get the total number 10,000. So you will get 5. So total volume will be 5. So 50 lakh. So 5 million. So 5 million count will be there. Clear? And that is if. And after that you have to discussion. So if count is normal, high or low. If count will be if total count will be within the 4.5 to 5.5 million, then count is normal. If more than that, then you can say polycythemia, or less than that, then you can say anemia or count is less. So let's some important topic. Let's describe about some important things. So in spite of the utmost precautions, the error count is around 20% plus minus. Why? Because this is a manual method, and chances of error will be more, because if you are taking the less blood or you are doing any mistake during the procedure, your count will be disturbed. So first is the pipette area. So pipette is not proper, size is not proper, bulb is not proper, maybe the manufacturing defect of pipette, or chamber error. So again I am talking about the manufacturing error. Chamber size very small. If slight change of the chamber size will change reflection will be very high, or error will be very high, because one extra count reflect as a 10,000 extra count, or one less count will be reflected final number 10,000 less count. So if slight error in the pipette or slight error in the chamber, obviously your count will be more or less. Okay, so disturb. Then counting error. This is the actually counting error. Counting error, why? Because we have to take reference line is in the central reference line, and reference line is triple line is there, and we have center line. Okay, so triple line and center line we should consider as the reference line, and if upper and left we have to consider inside the box, and right and lower we should consider outside the box. Okay, or it should go in the next cell. But slight error in that counting, it will reflect 10,000 cell, obviously I have already discussed. So error will be very much high. And the field error, while focusing you are not going to focus properly, so slight change in or missing the cell, again reflect will be the number will be very much high. So that's why error is very high. So again I am going to repeat all the slide in rapidly. So total RBC count, we know the 4.5 to 5.5 million per cubic millimeter of blood per microliter or cubic millimeter of blood or millimeter cube. So same thing, which is very small number. 1000 microliter is equal to 1 microliter, 1 ml. 1 ml is equal to 1000 microliter, or 1000 millimeter cube is equal to 1 ml. Okay, so this number is very small. 4.5 to 5.5. Male is higher number because of the testosterone, and female is estrogen and menstrual loss. So that's why female has less number. Okay, and male is slightly higher number. But this is the cutoff range. If more than that, you can say polycythemia, less than that anemia. Why anemia? RBC, because anemia means hemoglobin, decreased hemoglobin. So why anemia? Because of the less RBC count, because hemoglobin always remain inside the RBC, and maximum filling of this RBC is done by 33.3, suppose 1/3, I am talking maximum 34% RBC filled, RBC volume, this size of the RBC, and whole size you can fill maximum with the hemoglobin maximum 34%. For convenience I am taking 33.3 or 1/3. Okay, not more than that. So if RBC count is less, obviously if hemoglobin is filled completely but total RBC count is less, then obviously even though if RBC is filled completely with the hemoglobin is completely filled that RBC, even then also if you count the 100 ml of blood, then you will get the less number of hemoglobin percentage because of that. So that is one thing. So here we discussed about that. Now different type of method of RBC counting. We have manual method or hemocytometer with slide. So that's we will have already discussed. Then automated method. Two type of automated method we have: impedance counters, which detects the change in the electrical resistance by the cell while passing through. So cell is passing, and while passing this will through the chamber, it will change the electrical resistance, and that will be counted as a 1 pulse, and 1 pulse is 1 cell here. Then flow cytometry counters by using laser technique. So laser is there. In this technique we have detector, so light is passed, and then absorbent here detector is there. It is going to absorb the light, and then we'll get the number. Obviously cell is passing, and detect the number, volume, and internal content based on the size and granularity of the cell. So based on the size and granularity of the cells, so then we also get the what is inside the cell, how much content inside the cell, everything. So this is the microscope. So microscope, this is the hemocytometer box where we have newer slide, RBC pipette, WBC pipette. Then this is the cover slip, lancet, this is speed saw, and we can prick finger and take blood, simple or directly we can take the from venipuncture, and we'll do the test. Now we have diluting fluid which is called Hems fluid. Hems fluid composition is sodium sulfate 2.5 gram, then sodium chloride 0.5 gram, mercury chloride 0.25 gram, distilled water. So function I have already discussed: sodium sulfate anticoagulant, then sodium chloride isotonicity provide, then mercury chloride we can add as the antibacterial, antifungal, then distilled water we have 100 ml to dilute the fluid. Now let's next slide. So principle of this, we must know the principle, as the RBC count is millions, so that should be diluted blood, so we can count cells separately and can be counted. So for that we have to dilute the blood 200 times with isotonic fluid, and it should prevent coagulation, so that must be anticoagulant must be there. Now let's see, this is the improved Newer slide. This is the side pillar here, and this is the counting chamber, and this counting chamber is depth is lower than the side pillar, 0.1 millimeter. This is the RBC pipette with the red bead and white bead, the WBC pipette. So this actually identification point. We have two identification point. RBC pipette has a red bead and WBC pipette has a white bead. Then RBC pipette has a 0.5, 1 and 101 marking. WBC has 0.5, 1 and 11 marking. Bulb size is lower in case of WBC pipette. Bulb size is bigger in the RBC pipette. These are the basic difference, and this is the WBC pipette white and this is red. One more thing, what are the function of three function of bead, this red or white bead? One is the mixing of fluid with the blood. Okay, first point. Second point, identification. So red bead RBC pipette, white bead WBC pipette. Third one is the, if this instrument or pipette is wet or dry, that will get about idea with this bead. If bead is sticking on the wall, then we can say this is wet, not dry, and we always use the dry and clean pipette, we should always use. So if wet, it will stick on the surface, and if it is dry, then it will move freely. So to wet or dry we can check. Okay, and we should use dry always, clean and dry. So mixing of the blood, identification RBC or WBC pipette, and we can also check wet or dry pipette. This is the RBC pipette and this is the WBC pipette, and this is a newer slide. Yeah, so now we have seen this is the gap of 0.1 millimeter, this depth is 0.1 millimeter, this side pillar is 0.1 millimeter higher. This is the counting area. This is the counting area. When you focus under the 40, total magnification 40, 95, 40 times, then we will see this area 3 millimeter. This is the WBC area, WBC. We will count WBC in 10x magnification, means total magnification will be 100x. And this is the RBC area. So when we will focus RBC area, we will get 25, 1, 2, 3, 4, 5 into 1, 2, 3, 4, 5, 25 boxes. Okay. And when you focus under the 40x magnification power, total magnification will be 400x. So we'll get this area, and here we'll count 5 this type of a box. This is the one box. So 1, 2, 3, 4 and 5 box will count, 4 corner and 5 and 1 center. Why 4 corner? Because if you count all the 25, it will take lots of time. So we will count 5 and 4 corner and 1 center. Why? Because it will give you average number. Otherwise one side will have more cell and another side will have less cell, then counting will be difficult, or wrong number will get not actual number. So that's in the basic. And now we'll know after the preparation. So first we'll take the 0.5 blood, then 101 fluid, up to 101 fluid, then stem part will discard, 101 minus 1 stem part will discard, then final volume will be 100 and blood will be 0.5. So total dilution is 200 times, and then we'll charge it after discarding stem part under the microscope 40x and focus it, and we'll get the cell like this. Then after focusing, we must consider this triple line center line will be the reference line, and any cell touching the center line from the upper and left side we will consider inside the cell. With the same formula, if any cell touching the middle line or center line, we will consider is the outside the cell or next box. So we'll consider this cell in the next box. all the cell. Okay, so this cell will be go in the next box. So this cell will go here and this cell will go to the next box. So central line is the reference line. Any cell touching the central line, we should consider the cell either inside or outside. If left and upper, then consider inside the cell, and right and lower outside the cell. Outside the cell means right is actually left of the next cell and lower is the upper of the next cell. So this is the upper of the upper and this is the left of this box. So that's why we should consider this. So this is the calculation where dilution factor we have to consider and volume we have to consider 200. So first thing, we are not going to count normal blood, we have diluted blood. So dilution factor is 200 times, we have to consider that. And volume is not 1 microliter or 1 millimeter cube, but 1 by 50 microliter or 1 by 50 millimeter cube. So to convert it 1 millimeter cube or 1 microliter into 50, so total is 10,000 x. So whatever cell you will get that volume 1 by 5 to 1 by whatever cell RBC you will get in the 1 by 50 microliter of blood into, you have to do 10,000 and then you will get the actual final number. Clear? And that is actually the RBC count. So read it nicely. That